Hey guys, what's up? It's your pal Dave again, back in the lab. Once again, I was just here yesterday, but now I'm back again and I'm going to work on some actual stuff today. Yesterday I was doing retro gaming and no fooling around today. I'm actually going to do some work. Okay, so this involves the controller once again, because, once again I thought I was done and turns out there's still more stuff people want from this thing. So this one's a little interesting. I got an email from a guy in Singapore who wants to use this circuit to build a custom lighting controller. And it accepts MIDI commands, so it should be totally possible. Hey, I am Abel. Thanks for joining me. Yes, you finally made it. So that's what we're going to do. We're going to try to convert this into a custom lighting controller. Now, so it should be a simple thing, right? Because MIDI contains MIDI CC messages, which are designed exactly for what this is trying to do. Like, you're using it as a controller, and CC messages, or continuous controller messages, are designed to control things, right? Makes sense. So the MIDI designers actually thought of this ahead of time. But for some reason, the MIDI board this guy is trying to connect to doesn't behave normally. Like, they said, hey, forget your MIDI conventions and rules. We're going to come up with our own thing. So there may be some reason why they did it this way, but I don't know why. But anyways, I think we can make it work. So basically, I'm going to show you. This is the company that he's going to use their gear. So it's called ChamSys. And if you look at the pictures, it looks like they do some crazy stuff, right? So if I can have my little controller controlling some crazy stuff like this in Singapore, that would be pretty cool. I would think that's pretty neat. So anyways, so apparently their lighting board, it only responds to MIDI note messages, which is weird for a controller. Let me go back to the desktop here. So let's kind of go over MIDI note messages. So if you remember, MIDI note messages have three parts. The first is the command byte, which is 9, and then the channel number. So say like 90, right? That would be MIDI channel 1. Because remember, MIDI channels don't start at 0, they start at 1, but we write them in the byte as a 0 to 15. It's confusing. Yeah, whatever. And then the next byte is the key number, right? So it could be, say, 60, which I think is like a C, a middle C or something like that. And then finally it will have the velocity byte, which will be, I don't know, say 127. That's like full velocity, right? So this is a note. So a CC message kind of uses the same 3-byte structure, but it will start with like a different command. B, this is hexadecimal, like B0 would be MIDI CC number, and then it would have the CC controller number, which could be, I don't know, 27. And then it would have the data that the pot is sending to the thing. So that could be 0 to 127, right? So it makes sense that the lighting controller would be like, okay, MIDI CC controller number 27 is fader 1, and you can control it with this pot, and the higher you turn the pot, the light will get brighter or dimmer. That's how it would normally work, right? But for some strange reason, they're using note numbers to do the same thing, which, you know, doesn't really make sense to me. But, you know, hey, I'm not here to judge. So what we have to do is reprogram these pots to actually control the velocity of a note command, which shouldn't be that hard. In my head, I think it's doable and it's simple, but, you know, things don't always work out like you plan, right? So if all this stuff is kind of going over your head, all these byte commands and hexadecimal and all this stuff, what you can do is go to your friendly YouTube page and type in MIDI language. And one of the first videos you'll see is MIDI for the Arduino, Understanding MIDI Language, by this weird guy named Notes and Volts. Who the heck is that guy? And, you know, watch this video and it's going to explain, if you get through the commercials, it will explain all about the MIDI commands, MIDI hexadecimal notation, all that stuff. So if you can get past this guy's droning nasal voice, you'll actually learn everything you need to know about MIDI and how it works. So I would definitely do that. Also check out MIDI for the Arduino circuit analysis if you're building a circuit. It explains a lot. Not to plug my own stuff. All right, anyway, so that's what we're doing. So let's do it. Okay, so we need to get some code going. Yeah, there we go. Okay, so I've got my MIDI monitor up. And you can see right now as I turn the pots, you can probably see, if you can see close enough, the command status byte, they're calling it, is B0, which is a MIDI CC command, right? B0. The controller data number is 7, right? So I set that controller to 7. And then in this column is the actual data that you should see kind of going up and down as I turn the pot, right? And notice also it's on channel number 1. So what we have to do is change this so that the status byte is actually MIDI note byte instead. Yeah, so that's what we got to do. And no better time than the present. So let's open up some Arduino software. Where'd you go? There you go. All right, let me open it from the program here. So this is yeah, the latest version that we've been working on. So I'm going to save it as something else so we don't touch this one. I'll call it lights. All right, so this is now MIDI controller lights. And I'm not going to add this permanently to this code because it's such a weird thing. Like, I don't know why else you'd actually use this. So, you know, it'll be a one-off thing, but it'll kind of show you, you know, how easy it is to modify the program if you want. So, and that's kind of the cool thing about building your own stuff, because if you actually went to the store and ordered bought a MIDI controller off the shelf, and then you look for a command that would assign the pots to a velocity of a note, it would say, no, you can't do that. Why would you want to do that? What the hell are you doing? But since we're programming our own stuff, we can do whatever we want. So I don't think there's a way to do this unless we did it ourselves. Okay, so let's, enough of my going on, let's actually do some stuff here. So, all this stuff is, let's first look at a pot object. So remember, these are our pot objects, so pin number, that's the Arduino pin is connected to. Command, we're not going to do anything with yet. I could make a separate command for this, but I'm not because it's too weird and I don't want to add it to the program permanently. CC controller number, which is this column here, is what our CC control is. And finally, channel number is what MIDI channel will be on. So that's basically it. We don't have to really change anything here. What we have to change is we have to go down to this part, and these update functions are what actually update the controller, right? So the program basically reads the controls, and then this will take the value of the control and figure out what to do with it. So if we look at our update pots thing, it's a very simple function. So it's just like, a for loop for I equals, until I equals number of pots. That just goes through all the pots, right, that are in the program. And then it assigns this pot message byte to the value that it reads from the pot. And then it will basically send a control change, with the pot control number, the pot message, and I gotta scroll out, and the pot channel, right? So all we have to really do is change this. And I'm just going to copy it so I don't lose this. So we just have to change this line, if I'm thinking correct, to a MIDI note on command. And technically, I don't even think I have to change anything else. So I'm just going to try that and see what happens. So MIDI send note command is this, basically MIDI dot send note on, and then the 3 values you want. Where are we? Where's my thing? Okay, so let's try this and see what it does, because that might even just do it right there. So we're uploading. So you notice, oh, you can't see it. All right, so here we go. Now you notice all this junk that just appeared in my MIDI monitor, and that's basically because when I uploaded to the Arduino board, it's sharing the serial port with the MIDI, so like it's basically just sending the program to the MIDI monitor. The MIDI monitor is trying to make sense of it, and it can't, so it just like spews out a bunch of random nonsense. Okay, so let's see what happens if I turn the pot. All right, cool. So there you go. Now you notice when I'm turning the pot, let me, how can I do this? Let me move this over here. So much thinking I got to do here. All right, as I turn the pot, now you can see it's actually a note on command, and the value that's changing is the data byte of the velocity, right? So the data 1 is the note number, right? Status 90 is MIDI on command, and data 2 is the velocity. So we're actually changing the velocity. Look at that. And note off. Okay. right, so we go all the way from 0 to 7F. And yeah, that's full range, 0 to 127 in decimal. Now, here's an interesting thing. You notice when I go to 0 on the potentiometer, it's actually, the MIDI monitor is showing this as a note off, right? But if you look at the command, it's still 9-0, which is note on. So basically the monitor here is smart enough to know that a lot of times, even though there is a custom command for note off, which is 8-0, a lot of keyboards will use like a note on command with a velocity of 0 as a note off, right? It won't actually send, a lot of things don't send separate note off commands. They just send note on with a value of 0. So the MIDI monitor knows this, and it's basically treating it, saying it's a note off. Okay, which is cool, but there's one problem. So this weird lighting rig actually requires a physical note off command when the parameter reaches 0. So technically, I think this is controlling the fader or the brightness on the lighting rig, and each note could be a different light. So what we have to do is when we get a value of 0 here, we have to actually change this message to a note off. So that's going to require something else. But at least we got this far. Now one next thing I want to do is I want to do the same for multiplex pots. So remember, multiplexers are these guys here. I did another video on it. But it basically adds a bunch of more inputs to the Arduino. So you could, like the Arduino only has 6 analog inputs, so that's only 6 pots. But if you use a multiplexer, you could put like 16 pots on it. So I have a different thing for that. So technically, I think all I need to do is change that the same way I did there, and then that will work too. I really hope this guy appreciates all this crap I'm going through for him. And I hope some guy in Singapore, when the spotlight hits him, is going to be all going to think of me back here in the lab. Okay, so send note on. Yep, that looks all right. That looks right. That looks right. Upload. Now, if this works, then every message should send the same thing. Yeah, cool. So these pots on the right side, I'm actually going through a multiplexer. And yeah, it's doing the same thing. Perfect, perfect, perfect. So it's even telling me what note I'm sending for each one. This is a B flat. This is a C sharp, right? This is a D. So cool. All right, so that's that part. So now we have to do the other part. Okay. So I just got to think here for a sec. Okay. So I'm going to do another if statement. So if pot message, where do I come up with these variable names, man? So if pot message equals 0, and let's encapsulate that. So if pot message equals 0, then send note off. So I'm just going to see if this works by itself. That's a good thing, like when you're programming, just like do little incremental changes and see when you actually break something. And then you'll know how to go back. If you tend to do too much at once and you really break something, then you know, it's very hard to figure out how to get back to where you were. So let's upload this. Now, oops, what the heck? If was not declared, capital I, F. See, stupid little error. And brackets around the thing. Come on, man. Think. Brackets around the thing. All right. There you go. So, all right, now if this works like I think it will, I will get nothing from the pot until I get to 0. Yes, and then I get a note off command. Look at that. So basically anything I do will not work. And you notice, all right, cool. So you notice the note off command is actually 80 instead of 9. So that's actually a real note off command. An old school, like your grandma used to make, note off command. All right, cool. That's good. Now where's that end? There. Now let's do an else command. Else. I'll copy this whole nonsense. Hey, hanging in, I am able. Still happy you found the stream? You're like, God, this guy's dry. So else, all right. Now I gotta watch how many brackets I put in here. All right, let's see what we did. What did I break? Everything's note off. Yes. All right, so, all right, oh, I forgot to change this. So if I change this to a note on, this should work. If everything is good and just and right in the world. All right, man, let's keep our fingers crossed. Let's see what we can see here. That looks good. So we can go up to 7F, and now when I go to 0, I should get a note off 80 command, and I do. Would you look at that? Unbelievable. Well, there you go. Some Singaporean performers going to be mighty happy. All right, good. Now we just have to do this. Do this to the multiplexed versions. No, I don't want there. I want it here. These bracket things, they always mess with my head. Like, I never know if I've got the right amount. But it will tell me because it just won't compile. Yeah, see, I didn't get the right amount. So expected declaration if. So that's that one. What's this one? That's that. So have I got an extra one? There we go. All right, so it should be note off. Now let's just check that part, make sure it works. What am I looking for? Brain not working properly. Yes, there we go. So these, remember, these three pots are through the multiplexer, and we got our note off thing happening. Cool, very good. So now and these should still work as normal. Yes, they do. Great. So now all I have to do is this little else thing. So that's if, where's the if end? Right there. No capitals, what are you doing? Else. So that should be note on. Looks plot do yeah. Let's go. Yes, good. This compiles. Nope, you're dumb. What did you do? All right. Once again, how did I get an extra one? Same thing. It's weird. All right. This could be it. All right. Let's go. Yes. 7F. And then MIDI off. All the way off. Great. Excellent. Off. I think I should be getting some kind of royalty checks for something. All right, cool. That's amazing. All right. Look at that. Mission accomplished. You agree? Yes. Good to have your seal of approval. So, well, since you're the guy on chat, do you have any questions? I think this is so specific to this one guy in Singapore. All right, there you go. I've made the Singapore performance industry go. Oh, you just bought your new first Arduino. Well, congratulations. You're in for a long and interesting journey. Yes, they do, I think. Yep. Okay, good, excellent. So I am able, I think I'm calling it a day because I've done my work and I've made the Singapore performance industry go. Oh, you just bought your new first Arduino. Well, congratulations. You're in for a long and interesting journey. All right, well, on that note, excellent, man. I'm glad you're here. Okay, dude, well, thanks for stopping by, and I hope this guy in Singapore appreciates this, and hopefully I will see you next time. So tell your friends. This is a fun place if you're a nerd. It's a good place to be. So I will see you next time. Have a good one, man.